So in this video, what we'll be understanding is how we can use TCL scripts to greatly reduce our work. Okay, so what we'll be doing is follow each and every step that we've been doing, and then equivalently we'll be observing our TCL console. Okay, so let us move ahead and create a project. So once you create a project, you go ahead and let us just name it as project underscore 111. So we'll stick to a default name, and then probably only one thing that we need to change is the board. Okay, so board will be choosing as Nexus 4 DDR, and then we'll hit finish. Okay, so this completes one process. So you'll be observing that there are some statements that are written on TCL console. Okay, so you'll be finding once we start our Vivado, so the statement that has been used to start our Vivado is start GUI. Okay, and then create project, the project name, right, and the folder or the directory where we'll be storing the project. Okay, so it is inside a users LabVIEW and then project underscore 111, right, and then after this we have a part number, the board that we have selected, right, and finally set property, board part, and then Nexus 4 DDR, so on and so forth, right. So now let us just open or create a new text file. Okay, so we'll just go ahead and we'll create a new text document. Okay, and we'll just go inside this. Okay, so now we have our Vivado, so let us just copy this thing. Okay, so we'll just copy it, we'll go ahead and we'll paste it. Okay, so this is the statement or TCL script used to create a new project. Now in fact you know that since we already created this project with 111 number and the project directory with 111, we cannot again create the project with the same name. Okay, so next time when you want to create a new project, you will just be changing this two things, the project name and the directory. Okay, and next thing that it consists of is the board part, which is our Nexus 4 DDR. Okay, so we'll just paste this as a second statement, and just we will be putting one line space so that the things become much more simpler. Okay, so now let us just close the project. Okay, the project that we have created, now we are closing the project. So once you click on a Vivado icon that is present on a desktop, this is what you'll be getting, right? So once we do this, what we can actually do is now to create a new project, what I can do is instead of 111, I can actually add it as 112, and then here also I'll be replacing it as 112. So if I just copy this and if I go in here where I have a TCL console, and if I just put in all the commands that we have, that is both the command. First one is to create a new project with a desired name that user have specified, and second one is the board part which we'll be using to develop an application. Okay, so now if I just go to an TCL console and if I paste both the statement and hit enter, okay, so you'll be noticing that now Vivado automatically creates a new window. Okay, and this greatly reduces our work. Now in fact, you if you remember the process that we are following to create a new template of a microplace, it takes around 2 to 3 minutes to create the basic template, and then we add a desired IPs. Okay, so if we can store the default statement that we are frequently using, or the default process that we are frequently using, we can greatly reduce the time. Like here, you'll be noticing at least we are spending a minute on creating a new project, but once we have a statement, we just need to change this to number. Okay, and in fact now once you have an idea that if you can create a project with a TCL console, you will also have a provision to open a project, right? So that I'll request you to go and look for the TCL script that can be used to open the project, and once you have that idea, you can actually locate the desired project and you can simply with a click can open the project. Okay, so now next thing that we always follow is creating a block design. Okay, so we'll create a block design, and once we create a block design, you'll be finding one more script is been added in a TCL console. Okay, so we'll just copy that script and we'll again paste it to our text file, right? So we'll just be copying this and then we'll just be pasting it inside the text file that we are creating, right? And again, this is something that is being added automatically, so we'll also add that thing, so the process won't be changing much, right? So these two are the statements that have been added after we create a block design. Next thing that we always do is to create the basic skeleton of a hardware. before actually adding a peripheral IPs or the IPs that we are targeting. So we go ahead and we search for microblaze. So once we search for a microblaze, you'll be finding it add one group and it create a BD cell, and that is the microblaze cell. Okay, so we'll just copy this three statement and we can go ahead inside our text file. We can paste it over here, right? Now again, we know that we'll be performing block automation and the memory that we'll be choosing is 64 KB. So we'll just hit OK. And then this will add the necessary reset and rest of the circuitry, right? From the past experience, you already have that idea. So it will take a bit of time, but you can observe that the scripts are continuously changing, right? So you'll be finding uh, up to this point, we have already copied. So this is something that has been added new, right? So we'll just go ahead and we'll just copy it and we'll then paste it over the text file, right? Now the next thing that we always do is to change or connect our clocking wizard to the desired clock source, which is a system clock, a board clock, and then the output clock we set the reset type to be off, active, low, and then this basically add this three statement. So we'll just go ahead and we'll just copy this thing and then we'll paste it over here. Now one line space actually helps us to clearly distinguish between the various steps. So if you decided to change something in the future, you'll have a good idea where to change, right? And then we can perform block automation. So this will connect the reset and clock to the clocking wizard IP, and this is the statement that has been added. Okay, so we copied till this statement, right? So you'll be noticing that we copied till end group, and then these are the statements that have been added, right? So we'll just copy them and we'll just paste it over here, right? So this is the first statement that we have. Then this is the second one, which is used to connect the clocking wizard IP to a system clock, and then we connected the reset to the onboard reset pin that we have. So we just paste. Finally, we have something called as an end group. Okay, so we'll add that thing also. Okay, so this completes the process, and then we used to do is to regenerate a layout. So that thing also we'll be copying. Finally, we validate our design, right? So if everything goes fine, we'll be getting a validation successful message. So this is the basic skeleton that we've been using frequently, right? And for all the design, we require to initialize our skeleton like this, and then we can add the desired peripheral, okay, up on the top of this. So this is something that will be frequently requiring, right? So it is always a good idea that copy this, paste in a TCL console, and then the TCL script will handle everything. We do not have to do anything. So just to demonstrate, what we can do is I'll just close this project. Okay, I'll just clear this console. So here you have an option to clear a console. We'll just clear it, and then now we know that this belongs to project 112. We'll just change it to 113 and this also to 113. Just copy this. We go ahead and now we just go to the and we can just paste entire script. So you'll be finding we have pasted an entire script along with the spaces. So it doesn't matter, spaces have been simply ignored by a TCL console, and then we can just hit enter. Now we'll be finding that automatically we will be getting the basic skeleton, and this greatly reduces the amount of work that we need to frequently do, right? Now you remember, you just pasted the script and then you have an entire skeleton ready.